Okay, hello everybody. So today we're gonna start with 11.6 and it's called the ratio and root test. Now, sometimes we need to determine how quickly the terms of a series are decreasing or increasing. And to do that, we calculate the ratios of consecutive terms. So if you have limit, let's just say, of an plus 1 over an as n approaches infinity equal to a number L which is less than 1, then the series n equal 1 to infinity is absolutely convergent. We've seen that in the previous section. Absolutely convergent, which means it's therefore convergent. So if we take the limit as n approaches infinity of the ratio of an plus 1 over an, and that would give us L a number less than 1, then it's absolutely convergent and convergent. Now, if the limit is greater than 1, if the limit of an plus 1 over an is some number that is greater than 1 as n approaches infinity. Sorry, here I'm talking about the terms. Okay. Or the limit of an plus 1 over an as n approaches infinity equal to infinity, then the series is divergent. Now, if it's equal to 1, the ratio test is inconclusive. The ratio test is inconclusive. So that is, we have no conclusion. No conclusion can be drawn about the convergence or divergence of the series. Of the series. Okay, this is what we call ratio test. So let's do a few problems here. So let's do number 1. Number 1 is relatively easy, but we can do this. Just try for the first problem here. What can you say about the series, sum of an, in each of the following cases? So part A, the limit as n approaches infinity, an plus 1 over an is equal to 8. So notice here the limit of an plus 1 over an equal to 8. So that's greater than 1, isn't it? So what does that mean? When you have the greater one, then the series is divergent. Right? So this is, by the way, part A. So part II of the ratio test tells us that the series is divergent. So this is part A. Let's do part B. The limit plus 1 over an as n approaches infinity is equal to 0.8. And as you can see, this is less than 1. So part I, the first part of the ratio test tells us what? That an is absolutely convergent, and which means it's convergent as well. So this is part I of the ratio test tells us that the series is absolutely convergent, and therefore it's conversion. Okay, so this is part B. Part C, this is equal to 1. So what does that mean? So the limits of an plus 1 over an equal to 1 as n approaches infinity, the ratio test fails because it's equal to 1 here. The ratio test fails. And the series might converge or it might diverge, so we don't know. So let's do more problems now. Okay, so let's do number 3. In number 3, I have the sum of n over 5 to the n, and going from 1 to infinity. Okay, so this is an right here. It's n over 5 to the n. We need to have the n plus 1, which is what? N plus 1. Replace n with n plus 1, and I got 5 to the n plus 1. So using the ratio test, what do? We got the limit as n approaches infinity of an plus 1 over an is equal to the limit as n approaches infinity an plus 1. This is an plus 1. So n plus 1 over 5n plus 1 divided by an, which is n over 5 to the n. And that is give us equal to what? Limit as n approaches infinity, n plus 1 over 5n plus 1 times 5 to the n over n. You can do it directly. You can skip that step. I just wanted to do it the first time here. Oops, here, absolute value. So let's simplify it. What's 5n plus 1? That's the same as, we're going to do a little bit of algebra here, n plus 1 over 5 to the n times 5, isn't it? Right? So laws of exponents, and what happened here, the 5 cancel with the 5 to the n, right? And what do I have left here? I have 1/5. Remember, that's the same as, I can pull it out, can I? This is the same as the limit as n approaches infinity of, let me rewrite this, that's 1/5 times n plus 1 over n absolute value. So I can pull out the 1/5 out. So what does that give me? 1/5 limit as n approaches infinity of n plus 1 over n. Okay, now if we divide everything here by n, right, what does that give us? So this divided by n, here divided by n, here's divided by n. So I get the limit as n approaches infinity of n divided by n is 1 plus 1 over n over n, that's 1. And what does that give us? I don't need the absolute value anymore, right? Because this is positive, 1 over n is positive, and approaches infinity, so you can just use parentheses here, right? So what does that give us here? Oops, I forgot the 1/5. So this approach, as n approaches infinity, this approaches 0. And what do you have here left? You have 1/5 times 1, which is 1/5. Now, if you recall, the limit of n approaches infinity of an plus 1 over an is equal to 1/5. Isn't 1/5 less than 1? Right? So, what does the ratio tell us? If this limit is less than 1, so what does that mean? Then the series is absolutely convergent, and therefore convergent, right? And that's what we have. So the series sum of n over 5 to the n, and going from 1 to infinity, that's our problem, is absolutely convergent by the ratio test. By the ratio test. So this is number 3. So let's do one more problem. Here is number 4. They want to ask us to determine whether the series is convergent or divergent. Okay, so you have an is negative 2 to the n over n squared, and an plus 1 is negative 2 to the n plus 1 over n plus 1 squared. So using our test here, the limit as n approaches infinity of an plus 1 over an is equal to the limit as n approaches infinity. An plus 1 is this, so it's negative 2 to the n plus 1 over n plus 1 squared. You don't have to write it on the side, maybe you can see it from here directly. Okay, divided by an, or you can flip it directly, so you have times n squared over negative 2 to the n. So this is an plus 1 over an. So we're going to simplify just like we did before. This is the same as negative 2 to the n times 2. So this is the limit as n approaches infinity of negative 2 to the n times negative 2 to the 1 over n plus 1 squared times n squared over negative 2 to the n. So you see this is going to cancel out here. Negative 2. Okay, so you have here negative 2. So this, the absolute value of negative 2 is going to come out as 2, right? So this is going to be 2. Okay. Limit as n approaches infinity of, you have n squared here, this is 1, this 1, so n squared over n plus 1 squared. Alright, so I hope everybody's okay. The absolute value of negative 2 is 2, and this came out as 2. So if you divide n here, if you did this by the highest power here is n squared, right? If you want to expand it, you can expand it, but you can see it. I don't know if you can see it from here, but if you can't, I can do this. 2 limit as n approaches infinity over n squared over n squared plus 2n plus 1, right? So you divide this by the highest, which is n squared, n squared, n squared, and n squared. So what does that give us? 2 limit as n approaches infinity of n squared over n squared, that's simply 1 over n squared, that's 1, plus 2 over, one of the n's cancel out, 2 over n plus 1 over n squared. And that gives us what? As n approaches infinity here, these are going to approach 0, right? So what is that going to give us here? So that's going to be 2 on the outside times 1 over 1, or simply 2. But isn't that greater than 1? So what do I have? I have the limit as n approaches infinity of a n plus 1 over a n greater than 1, right? So the series is divergent. It's divergent by the ratio test. Okay, so this is number 4. All right.